There's a single angle. I guess it'd be like sine alpha equals square root of 1 minus cosine squared alpha. That'd be a single angle formula. Double angle formula. We did double angle formulas on the test.
We just didn't know.
You just didn't know. Well, most of you did. Some of you chose to avoid this problem. It was one that we did for homework that I answered in class from the homework, and I basically told you on the test to study these two problems. And some of you may recognize, or some of you I've never seen that in my life. It was the sine of 2a.
That was so easy. That was so easy.
Same thing. We'll do the next one. Yeah. All right. That's a double angle. Double angle because there are double of them. If you have one, you double it. Double mint gum. Double angle formula. Now on the test, it might have been cosine of 2. I forgot which one I gave you. But on the test, you would have said, well, this is just sine of a plus a. And then we use our sum identity to rewrite this as sine of a cosine of a plus cosine of a sine of a. Well, I can rewrite that as sine a cosine a plus sine a cosine a.
Wait, should we put this down?
I mean, you don't have to.
I didn't know. I have like a slide.
What was that?
I didn't know if you were going to have a slide there or not.
Oh, it is. See?
No, I mean like something comes up there.
Oh, I gotcha. No. I don't have anything that comes up on your sheets. That'd be magic.
Okay.
All right, so this is just x plus x, which gives me 2x, or 2 times sine of a cosine of a. So sine of 2 times a number equals 2 times sine of that number cosine of that number. So maybe this is 70 degrees. Maybe it's 2 times 70 degrees. You just take that 70 degrees, you chuck it in here. Here's the good news. You don't need to memorize this. And why don't you need to memorize it?
You could just work it out.
Because you can just work it out. And even better, I'm going to give you an identity sheet that you can use on the test that will have this strictly written out that says sine of 2a equals that. All right, so that's our sine double angle formula. Let's go ahead and do cosine double. Notice the space is a little bigger. Try to stay with me. Try not to fill it all up with just one, because there's going to be 3. So follow the spacing that I'm using. So we're going to do cosine of 2a. It's got to have 2 times something to be a double angle. That might be a little bit too small, but that's okay. Is going to equal cosine of a plus a. But that's just a sum formula. Cosine is cosine cosine minus sine sine. So we're going to have cosine of a minus sine a sine a. Well, that's just cosine squared minus sine squared. That's just cosine squared minus sine squared. But notice I did not fill up the whole box, not entirely. I got 2 little spaces down there. You should have a little bit more because you don't have to write as big as I do. Cause you should. I got to write big enough that everyone can see it. Remember, and some of us might want to remember this for a problem on the test when we correct it. If I want to write this whole thing in terms of cosines, I can. If I want to write this all in terms of sines, I can also do that. So let's focus on the sines one. I want to rewrite this with no more cosine squareds in it. Well, hold on for a second because we have cosine squared a. Well, I can rewrite cosine squared as 1 minus sine squared because it comes from our cosine squared plus sine squared equals 1. That was a big thing that was on the test. If you remember, there was one that had all sines on one side and one that had cosines. If you just rewrote either side in terms of the other one, it was a very easy problem. So we're going to go ahead and rewrite this. Take out the cosine and rewrite that as 1 minus sine squared a minus sine squared a, which I'm going to have to get right down on the bottom, but it's just going to be 1 minus 2 sine squared a. Let me close that parenthesis. All right, and the other one is just rewriting everything in terms of cosine. So that's going to equal cosine, let's shorten this up a little bit, cosine squared a minus 1 minus cosine, squared a. I got it in there. I got it in there. It was real close. It was. Look how close I am to the edge. I had to like do that thing where you curve up. You ever do that in your notebook paper where all of a sudden everything curves up?
I do down usually.
Oh. There's people that go down, there's people that go up. I'm not saying which is better, going up is better, but we need to distribute this negative sign. So it'd be cosine squared minus 1 plus cosine squared. So it'd be cosine squared plus cosine squared, which would give me 2 cosine squared alpha, or a, minus 1. I forgot to change my alphas to a's. Makes it a little easier to write sometimes. 3 formulas. Why is it important that we have 3 formulas? It's not terribly important right now, but we're going to have to use these to verify equations. When we have to verify equations, it's going to be important to know all 3 of those. Because picture your time where you have to verify one, and you might look at the right-hand side, and everything is just signs. It's signs across. So that would tell you to use the one with just sine squared in it, because you want to get rid of all your cosines. Maybe there's one that just has cosines across the board. Then you use this one. Maybe you look at the other side and you have a bunch of sine squareds, cosine squareds. It will tell you to use this one. And sometimes you just got to try one, and if it works, awesome. If not, you go back to the drawing board. So these have 3 possible ones. Double angle. That is my cosine double angle. Tangent just has 1 possible value, so let's go ahead and do it. Tangent of a double angle, or 2 times a, is the same thing as tangent of a plus a, which is going to equal tangent of a sum is tangent plus tangent over 1 minus tangent times tangent. So that's going to give me tangent a plus tangent a on top, all over 1 minus tangent of my first angle, which is a, tangent of my second angle, which is also a, which simplifies down to just 2 tangent a, all over 1 minus tangent squared a. With double angles, 2 very important things. It's got to have a 2 out front in order for it to be a double. Has to be a 2. And there has to be a number after the 2. It could be 1, but the 2 important things are this 2. The 2 lets me rewrite it. Whatever number comes after the a is the number we're inserting everywhere. Now, it might seem like it makes sense right now, but someone in here is going to mess it up terribly. They're going to take this whole thing and plug it all in there. They're going to take 2a and plug it in here. So say this is 2 times 60 degrees. They'll take 2 times 60 degrees and plug the whole thing in here. The 2 just lets me rewrite it. The number after is what we're inserting. All right, so remember that. I need a 2, and I need a number after it. So my next thing says find the following using your double angle identities. Yes, I know you can go to Unicircle and say the sine of 120 degrees. It is on there. Yeah, it's going to be 60 plus 60, but we're not going to write it that way. We want to write it as a double angle. We want to write it as
2 times 6.
I want a 2 times 60. I want to rewrite sine of 120, and it says double angle, so I need to have it equaling sine times 2 times something, and that something has to be 60 degrees. I always focus on the 60 degrees as being the most important part, because the 2 lets me rewrite it, but the 60 is the one that I need to insert into the equation. So we have sine of 2. That lets me know I can rewrite it. So we're going to rewrite it as 2 times sine of 60 degrees, not the 2 times 60, but just the 60, times cosine of 60 degrees. Well, 60 degrees is pretty easy peasy. The sine of 60 degrees is square root of 3 over 2 last time I checked, and the cosine of 60 degrees was 1 over 2 last time I checked. I hope it stayed the same and no one changed it on me. But that's just 2 times square root of 3 times 1, which is 2 square root of 3, over 2 times 2, which is 4. Well, that's just going to equal square root of 3 over 2. And I want to check something really quick. So my original thing was sine of 120 degrees. I want to be able to check to make sure it should be positive or negative. Well, this 120 degrees is in the second quadrant. Sine is positive in the second quadrant, so square root of 3 over 2 is correct, and it should be positive. Well, cosine of 120 degrees should also be in the second quadrant. But that means my next one should be negative, because only sine is positive in quadrant 2. So let's see what happens with cosine of 120 if we use this strategy. So we're going to have that equals cosine of 2 times 60 degrees. Once again, the most important part is probably the 60 degrees. The 2 just tells me to rewrite it. We have 3 possibilities to rewrite it. In this case, it doesn't matter which one you pick. None is really harder than the other. Really doesn't matter which one you pick, so I'm just going to pick the cosine squared minus sine squared because it's the very first one. If you picked a different one, you don't have to erase it. Just make sure you get the right answer. So I'm going to say, since it's double angle, I'm just going to use the cosine squared of that 60 degrees minus that sine squared of that 60 degrees. Once again, cosine of 60 is 1/2, so we'll have 1/2 squared minus square root of 3 over 2, also squared, which can give me 1/2 squared is 1, squared is 1, 2 squared is 4, so it's 1 over 4, minus square root of 3 squared is 3 over 4. 1 minus 3 is a negative 2. Negative 2 over 4 is negative 1/2. So the good thing is, when using this double angle formula, it'll actually give you the negative. Even though we're using 60 degrees, it still gives us that negative 1/2, which is nice. Yes?
I did it the other way and I somehow ended up with positive 1/2.
We did it wrong.
Oh, shucks.
What'd you do? Oh, you did the... Well, the sine squared of 60 is square root of 3 over 2.
Oh.
All right, tangent of 120, it's all the same, so let's just plug through this. It'd be tangent of 2, need it to write it as double. I need the 60 degrees to plug in, so that's going to give me 2 times tangent of that 60 degrees all over 1 minus tangent squared of 60 degrees. I'm going to pause really quick.
Oh, yes, you can.
Just because I want to say, there are times where you have to go backwards. So I might give you this. You just have to realize with double angle, you have to put this 2 in here. All right, so if I'm going backwards, don't forget about this 2 out here. Okay, that being said, let's simplify this. Tangent of 60 degrees is our second easiest tangent because it's square root of 3 over 1 minus square root of 3 squared. That's just going to equal 2 square root of 3 over 1 minus 3, which is negative 2, which equals a negative square root of 3, which is awesome because I'm in quadrant 2 and tangent is negative in quadrant 2. And if you look at your unit circle, you'll find that all those values are correct. Are they correct?
Yeah.
Nice.
Why do we have to do all that to get to it?
Well, we'll have formulas that we won't be on the unit circle.
Okay.
I like to give you these. I might even give you one on the test that you can use your unit circle to check. Which would be nice because then you know if you did it right or wrong. But there are ones that you have to use the double that it won't be on the unit circle unless you're using the double angle. All right, the next 3 are half angle identities. We'll kind of show why they're true tomorrow, and on the printout, it'll actually have each one step by step how to do it. I just don't feel like doing it in class because you guys look super interested in wanting to see why they're true. Just take it on faith that it's true, and tomorrow I'll provide the reason to you. All right, so each of these are true. The cool thing is, if I made you memorize these 2 are almost identical. And we're going to take use of the fact that these are identical, almost identical, tomorrow. It won't matter too much today. But the only difference is a positive and a negative. Tangent. There's 3 possible half angles for tangent. Notice the one that's bolded. Generally, if I'm not using an identity, maybe I know the tangent of 60 divided by 2. I would probably pick this one to solve. It's generally the easiest one. Because why pick the one with square roots, the top one, if you don't have to? So in general, if you can pick either one to make it work, pick this one. For identities, you might have to use each one. Nope. I'll give you an identity sheet that you can use on the test, and I'll give you stuff that you can write on the identity sheet too to help you on the test. Okay. Double angles, I need a 2 out front. Half angles, I need a 2 in the denominator. Notice our first problem does not have a 2 in the denominator, so I need to rewrite it. And a problem like this on the test would tell you to use half angles. All right, so you'll know right away, half angles, oh, I need something over 2. So you would immediately in your head think, let's draw that a little better. You would think immediately, I need something over 2. The easiest way to do that is just take the 8, divide it by 2, and it'll give you 4. And why that works, so this should be pi over 4 over 2. And why that works, this 2, using keep, change, flip, you'll find out, is just multiplied by the 4. So to get this back out, I just do 2 times 4, which would give me 8 back up. All right, so pi over 4 divided by 2 does equal pi over 8. Now I have the 2, and what I think is the most important part is that pi over 4, because it's going to kind of tell you you did stuff right, because pi over 4 is on the unit circle. On the test, if I give you a problem like that, and that number on top is not on the unit circle, you made a mistake. All right, it should be on the unit circle because we can't go much further if it's not on the unit circle. Pi over 4 is, so I'm pretty sure I did it right. We're going to use the half angle, which is plus or minus, and we know whether it's plus or minus from this pi over 8. That pi over 8's in quadrant 1, so my answer is going to be a positive square root of 1 plus cosine pi over 4 all over 2. Notice the 2 on the bottom just lets me rewrite it. The pi over 4 is the most important part. All right, simplify this. Let's simplify it smarter, not harder. And what I mean is on this one step, we're going to have 1 plus square root of 2 over 2 all over 2. Some of you are going to try pushing together 1 and square root of 2. which will make you rewrite 1 as 2 over 2, push it together, which will give you 2 plus square root of 2 over 2, keep, change, flip, blah, I'm already bored of saying it. Let's be smarter about this. Let's just say I want to get rid of the fractions. I want to get rid of the fractions, so multiply by 2. I'm not allowed to just multiply by 2. I have to multiply by 2 on the bottom as well, because that's actually multiplying by the fraction 2 over 2, which is the big 1. Just don't forget that 2 has to be distributed across the entire numerator and denominator. So this is something that you could probably do in your head, this first step. So this would be 2 plus square root of 2 all over 4. This is the only time I'd ever write this step, because you should be able to do this in your head. But remember, you can split apart fractions with radicals as a radical of the numerator and a radical of the denominator, which should equal, remember, it's positive, square root of 2 plus square root of 2 all over 2. That is fully simplified and done. You can't go any further. Don't try to go further. I will take off points if you go further. You can have square roots under square roots under square roots.
You just did something right there. In that middle part,
You did sorcery.
You kind of just.
Now I see what
I did not see what that.
Which, from the arrow?
In the middle. In the middle. Right there. Yeah, I don't know.
From here to here?
Yeah. Yeah. Why did you do that? Why did you put everything under square root?
We started under a square root.
Okay.
So we're okay with the square root here?
Oh, okay.
Are we okay with the square root here? Is it just this step? I'm just trying to figure out where the question is, I guess.
Yeah, I don't know. I just didn't really get that part.
From here to here.
Yeah.
Okay. That's why I wrote it on there. If I ever have something like square root of 3 over 4, I can rewrite it as the numerator squared over the denominator squared. That's all I did. I just separated so you could see that the bottom was in fact 2. Most of the time I would just jump straight to the 2. Alright, but that's why I can do that. That's a property of exponents, that if you have a fraction under a radical, you can put the numerator under the radical and the denominator under a radical. Oh, I forgot that. Practice it, because I'm going to be looking for that, because that's fully simplified. This is not. This one is. All right, last one is find sine of 75 degrees. Once again, I'm using half angle identities, so I need something over 2. I need something over 2. So I'm just going to rewrite this as sine of something over 2. Well, it turns out 150 degrees is that guy. Remember, the most important part is that 150, the 2 just lets me rewrite it. Well, sine is pretty close to the cosine formula, which is just square root of 1 minus cosine of 150 degrees.
Why are you using cosine again?
All over 2. They both use cosine, actually.
I was looking at the tan table.
It's actually pretty incredible that they both use cosine. It just makes our life a lot easier. You'll see tomorrow. Otherwise, tomorrow would not exist. Maybe you aren't happy that would happen.
It's going to be positive.
It is going to become positive because we are in quadrant 1, so our answer is going to be positive. We're also going to have 1 minus, well, cosine of 150 degrees is negative square root of 3 over 2. All over 2. Well, a negative times a negative, or if I'm 1 minus a negative, it becomes a positive. I'm going to tell you right now, make your life a lot easier by getting rid of your fractions first. So I'll multiply the top and bottom by 2. That's going to equal square root of 2. Ooh, I made that really big. Plus square root of 3 all over 4. Once again, there's no magic happening, but it just becomes square root of 2 plus square root of 3 over 2. And like I said, it's positive. And I'm almost positive that's correct. Any questions? Does anyone see any sorcery up there that just doesn't make sense? Besides, you have to take this on faith for right now. Good otherwise? All right, the rest is homework. I am going to hand back your